Right, so today I am discussing a problem related with how to calculate the required engine power. Okay, so before calculating the required engine power, first of all we need to know what is the required wheel power. Okay, right. So now when calculating the required wheel power, there are certain types of resistive forces, right? Because when considering those resistive forces, right, the engine has to produce related necessary power in order to overcome those resisting forces, right? Okay, so let's consider those resisting forces, right? So number one is the rolling resistance, right? The resistance due to rolling, right? The next thing is the aerodynamic drag, right? The drag due to the aerodynamic conditions, right? Okay, then the gradient resistance, right? Then this is a kind of a critical part. Okay, so required power for acceleration, right? So there I want to mention something. So how to calculate the required force for the acceleration? You know that is F equals ma, right? So if this F is the force required for the acceleration for a mass of m, right? So then what is the required power? Power is force multiplied by the velocity, right? But the fact is, if you are using this formula to calculate the required power in order to overcome the power due to the acceleration, then your calculation is wrong. Okay, so then actually that is not the way. I will explain you that, right? So then let's consider the input parameters. Okay, right? The input parameters are vehicle mass, right? So we have our vehicle mass 1700 kilograms, then coefficient of friction 0.02, drag coefficient, right? Aerodynamic drag coefficient 0.25, then the maximum grade, right? What is the maximum grade? 40%. That means that if you are going to consider this inclined road where the inclination is theta, right? If you are traveling 100 meters along this inclined road, right, ultimately you will reach to a height of 40 meters, right? So that is the meaning of maximum grade. So then from that we can form some relation. So what is the relation? We can say sin theta equals, what is sin theta? 40 divided by 100. Okay, so now we know that sin theta equals 40 divided by 100, right? So then we know that theta equals sin inverse 40 divided by 100. So if you calculate that, right, the answer will be 23.57 degrees, right? So be very careful about the angle, okay, with the degrees or radians. So like for our betterment, right, we will consider this as 24 degrees. Okay, okay, right. So now we are going to find all these resisting forces one by one. The first resisting force that we are going to find is the let's say rolling resistance, right? Okay, so now here when solving this problem, we are going to consider the maximum grade scenario, right? So that means according to this calculation, right, we are going to evaluate the wheel power based upon the scenario when the vehicle is traveling along the maximum gradient or along the maximum inclination, right? Okay, so this is our inclination theta here, right? This is the road, right? So now here I will sketch the automobile. Okay, right? So what is this? Mg, that is the weight. Okay, so right. Okay, right. So now we will first calculate the rolling resistance, right? Number one, right? So now basically in here, in order to calculate the total wheel power, right? One by one, we have to calculate the resisting forces, right? Because if you know all the resisting forces only, then we can calculate what is the required wheel power in order to overcome all these resistive forces. So rolling resistance, right? Rolling resistance, right? So now we know, right? In this calculation scenario, right? We are going to consider the inclined rod, right? So here we are going to consider something called rod inclination, right? Theta, right? And I think theta we have already evaluated, right? For theta we got something like 23 point something. So then for the betterment of our calculations, right, we have rounded it up to 24 degrees, right? Okay. So theta we know, right? So now this vehicle is traveling along the maximum grade. Okay, right. So now I will sketch the vehicle. Right. So now this is the vehicle weight. Mg. Right. So this angle is, if this is 90 degrees, this angle is 90 minus theta, right? This angle 90 minus theta, right? Okay. So now here we have to find the vertical and horizontal components, right? Because we have to resolve the forces. This is the horizontal component and this is the vertical component, right? Okay. Right. So now if this is the angle 90 minus theta, right? If this is the weight, what is this component? Mg cos 90 minus theta. So that is Mg sin theta. Mg sin theta. Okay? Right. Then what is this component? Mg sin 90 minus theta, right? This is vertical component is Mg sin 90 minus theta. That means Mg cos theta, right? M we already know, that is 1700 kilograms, right? But as this is a vehicle dynamic based calculation, better consider G as 9.81, okay, meters per second squared, right? So now what is the rolling resistance? Actually that is the resistive force, right, due to friction, right? So then what is the coefficient of friction? Mu, right? So coefficient of friction mu is given here, right? Okay. So we know that F equals mu r. We know this, right? So we know that F equals mu r, right? So if you know the normal reaction, right? Normal reaction is the force that is perpendicular to the direction of friction, because now the vehicle is traveling along the inclined road, right? So then the friction is towards the opposite direction, right? So the friction force equals mu times normal reaction. So what is the normal reaction here? Normal reaction is mg cos theta, the vertical component, right? Right? The vertical component to this inclined road, right? In other words, is not the vertical component, that is the perpendicular component to this inclined road, right? So what is the perpendicular component to this inclined road? That is mg cos theta. Actually, what is mg cos theta? Mg cos theta is the reaction force. So R equals mg cos theta, right? So then what is the friction? Mu times mg cos theta. So mu you already know, right? 0.02, m is 1700, g is 9.81. What is cos theta? Cos theta is cos 24 degrees. So what is the respected answer? 304.7. The answer must be 304.7 newtons, right? So this is the force, right, due to the rolling resistance that is actually caused by the friction, right? So F rolling, so Fr now we know, right? So what is Fr? Like all the obtained answers we will write it somewhere. I think that will be better. F right here, Fr, let's say Fr or double L, rolling resistance. Rolling resistance is 304.7. Check the answers. 304.7 newtons, right? Right, okay. So now we will calculate the resisting force due to aerodynamic drag, right? So in simple words, the aerodynamic drag is a resistive force, right, that acts along the opposite direction during the motion of the vehicle, right, that is caused through air, right? Simply as that. So now, as you know, according to this situation, right, at this particular situation, we are going to consider the travel of the vehicle along that maximum inclination, right? You know that. So now there is another story in here. So now consider these two different scenarios, right? So now here the rod inclination is theta, right, which is the maximum inclination, right? Here there is no any sort of inclination, right, because the inclined angle is 0 degrees, right? Now if you are going to consider the same engine power of the automobile, right, because now this is the same vehicle, right? So the engine power will be, or the design engine power will be the same, right? The design maximum power that cannot get changed, right? So for the same design power of the engine, right, the maximum velocity that the vehicle is attained during the maximum inclination, right, and the maximum velocity of the vehicle attained, or maximum velocity of the same vehicle that is attained when there is no inclination, what can you say about that velocity? Definitely the velocity v1 at here must be greater than v2, right? So that means along the maximum grade, the maximum velocity attained by the vehicle is limited, right? Okay, so now because of that, when you are going to consider the inclined scenario, right, we have defined that maximum velocity along maximum inclination theta is 60 kilometers per hour, right? So now what is the maximum velocity here? v2, 60 kilometers per hour, okay? That is attained within 10 seconds, right? So what do you mean by 10 seconds, right? You cannot instantly achieve the velocity, right? So in order to achieve the velocity starting from the rest, it takes some time, right? So we have defined that the maximum velocity of 60 kilometers per hour is achieved starting from rest within 10 seconds, right? So now I hope that is clear, right? So now how to find the aerodynamic drag? I have already explained you what is aerodynamic drag. So what is the direction? In the opposite direction. So let's call it F aero, A-E-R-O. Very simple formula, right? Nothing much to worry. Half rho, actually rho means the density of air, right? Half rho CD. What is CD? Coefficient of drag. That is already given. Half rho CD A V squared. Now here what is this V? The maximum velocity, right, attained by the vehicle. What is A, right? A is the effective frontal area of the vehicle, right? Because like the airflow hits the front of the vehicle, right? Front of the vehicle. So now what is this A? Effective frontal area of the vehicle. So according to this problem, the effective frontal area of the vehicle is given as, I didn't keep it here, right? Now I will give that data. What is this A? Effective frontal area of the vehicle. Actually that is 0.6375 meter square. That is the effective frontal area. Velocity we know, but be very careful about the units, right? Okay. Now it's very easy now. What is the answer? Half. What is the density of air? 1.225, right? Okay. What is the coefficient of drag? 0.25. That is given. What is effective frontal area? 0.6375, right? Or in other words, you can round this. Okay, doesn't matter. So what is V squared? Be very careful. 60 kilometers per hour. That means 60 kilometers per hour multiplied by 1000 divided by 3600 seconds. Whole thing square, right? Okay. So all checked. Half, rho, CD, A, V squared. So let's check whether you are getting the answer for aerodynamic resistance as 99.96 newtons, right? So we will write that answer here. F aero 99.96 newtons, right? Okay, right. Okay, so now we will next calculate the gradient resistance force, right? Gradient resistance, right? So what is the gradient resistance? That is the resistive force, right, that the engine has to bear, right, due to the weight of the vehicle, right, because there is a vehicle weight, right? So let's sketch the road inclination theta and the vehicle, right? So what is the weight of the vehicle? That is mg, right? So as you know, there is a component of this weight along the direction of the road, right, in the opposite direction of the motion, right, because the engine power must be produced, right, such that the design power can bear this resistive force due to the weight. So what is it? What is the angle here? 90 minus theta. 90 minus theta. So what is the weight component? mg cos 90 minus theta. This is mg, so we consider cos component. mg cos 90 minus theta. So what is cos 90 minus theta? Sin theta, right? So the force along this direction due to the weight is mg sin 90 minus theta, right? So what is the gradient resistance force? Let's call it FGR, gradient resistive force, mg sin theta, right? Very easy. So what is m 1700, g is 9.81, sin theta is sin 24. Check whether you are getting the same answer. I am getting it as 6783.1 newtons, right? So FDR 6783.1 newton. Okay, right. So now we have calculated all the resisting forces, right? So now we have calculated rolling resistance, aerodynamic drag, and the gradient resistance, right? So now the last resisting force that we have to calculate is the required power for the acceleration, right? Because as we know that in order for the vehicle to accelerate, we need some additional power, right? So that additional power must be prepared, or that additional power must be produced by the engine, right? Because the summation of all these resisting forces is actually the power that is required at the wheels, right? Because that is the minimum power required by the wheels, right? Okay, right. So now let's start. Now here there is a different approach, right? So let's see. Total minimum power required, right, by the wheels, right? Because now this is not the ultimate power produced by the engine, right? That's a different scenario, right? So here what we obtain by calculations is not the actual brake horsepower or the indicated power produced by the engine, right? Now, as you know, indicated power is a different scenario and brake horsepower is also a different scenario, right? But here what we calculate is none of the brake power or indicated power. Here we calculate the total minimum power required by the wheels, right? So what is that? That equals total resisting forces, right, multiplied by the maximum velocity along the maximum grade, right, or maximum inclination, right? Grade, or you can say inclination, right? So now here I have previously told you that we are going to consider the inclined scenario, right? The vehicle is traveling along the maximum grade, right? So now wait. So now what are the total resisting forces? You know that, right? Rolling resistance F R O double L. Let's say like that. Okay. Plus aerodynamic drag F A rho, right? Plus the gradient resistance. So let's say F G R A D, F gradient, plus required power for the acceleration F A C C, right? Now these four forces are the resisting forces times the maximum velocity. Velocity, you know what is that? 60 kilometers per hour, right? Now here it is mentioned achieved within 10 seconds. Till we didn't use that data, but wait, velocity V, right? So now just look at this one, F rolling, F aerodynamic, F gradient, right? We know the summation of these three forces. What is that? 7187.76. We know that. So what is the acceleration force? We know that force required for the acceleration is F equals ma, right? So what is acceleration? The first derivative of the velocity with respect to the time under F acceleration, right? M times dv by dt. In other words, F equals ma, right? Times v. So what is this? The total power, right? P total, right? So let's say P. Okay, right. So now P equals 7187. This scenario for our easiness, right? Let's write it as 7188, right? Because it will be easier for us to do the simplifications, right? So let's expand this. This times V, okay? Then this times V, this times V plus this times V, M V times dV by dt, right? So now consider the least common factor, right? Least common factor for the denominator. 7188 V times dt, right? What is the least common factor for the denominator? It is none other than dt, right? mv dv divided by dt, right? Okay, so now do the cross multiplication. P times dt, right? Right. Keep in mind that this dt is the derivative component, okay? Derivative component. because let's see what we are going to do for the next, right? So P times dt, 7188 V times dt plus mv dv, right? So now what we can do, integrate both the sides, integrate both the sides, right? So now here we have p dt, right? So the only possible way to integrate this side is with respect to time, right? This is the integral symbol, right? Equals 7188 V is there and dt also there. Okay, so doesn't matter, let's include the integral symbol, right? But we know that the only possible way to integrate this is with respect to time. So we can write this part as 7188 V times dt, right? Okay. So then integration of this part plus mv dv. So now if you are going to consider this part, the only possible way to integrate this part is with respect to the velocity, right? So then we can write this as m we can take out, right? M we can take out of the integral symbol, then v dv, right? Yeah. So now let's substitute the values and continue, and we have obtained up to this part, right? Okay, so then I will erase the above part and continue the simplification from here, right? Okay, so now let's continue starting from here, right? So now from here we have I will write it again, power, this is the variable that we need to find, integral dt equals 7188 v integral dt, right, plus m times, like m is the mass of the vehicle, right, m times v dv, right? So now here we are going to integrate, right, with respect to the related derivatives like dt, dt and dv there within the range, right? So if you are going to integrate, and after that if you want to obtain a certain value, we have to specify the range, right? Actually now I want all of you to recall the speed condition data, that is velocity along the maximum inclination theta is 60 kilometers per hour achieved within, right? So now see there you have to specify the time, right? That time is the interval that we are going to apply here within the limits, right? So now what is the limit there? If you are going to integrate, you must know the particular limit, 0 t, time limit 0 t, and here also, right, if you are going to integrate, you have to give the particular limit, but there what is the limit? Velocity, right? So this part m times integral of v dv, right, because you are going to integrate with respect to v, right? So what is the limit that you have to put? It's v, right? So the upper limit is a velocity, right? Write v here, right? So now here you have to be very careful. Let me tell you why, right? Because now we know that the maximum velocity is 60 kilometers per hour, right? That is attained within 10 seconds. Be very careful, right? So here the lower limit is 0 because that 60 kilometers per hour velocity is attained starting from 0, right? 0 to 60 within 10 seconds, right? So here if you are going to consider the integral where you have to integrate with respect to time, the lower limit is 0, the upper limit is 10 seconds. So it doesn't matter. But here don't substitute the values at once, right? Because you have to be very careful about the standard units, right? So here also the same scenario, right? Integral of dt with respect to time, right? So what is the lower limit? 0 seconds. So what is the upper limit? 10 seconds, right? Right. So in case here, after obtaining this integral, if you are going to apply 60 kilometers per hour as the upper limit, that means you are wrong, right? Because we have to keep the units in the standard format, right? So you cannot keep in kilometers per hour, so it must be kept in meters per second, right? Okay, so now let's try to find the answer for this, right? So if you integrate this one, integral of dt, so what is the answer? P times t, right? So what is the lower limit? 0 seconds. So what is the upper limit? 10 seconds. So it is okay. So if you are going to integrate this one, integral of dt, it is also same as the previous one, 7188 times v times, the answer for this is t. Lower limit is 0 seconds, upper limit is 10 seconds, right? Plus m times integral of v dv, right? So here you have to integrate v with respect to the derivative v. So what is the answer for that? If you integrate v with respect to the derivative v, what is the answer? V squared divided by 2 will be the answer, right? Here you have to put m, right? M times v squared divided by 2, right? So what are the lower and upper limits? Lower limit is 0 meters per second, upper limit is v meters per second. But be very careful here, when you are going to apply v, you have to convert the units. V equals 60 kilometers per hour means 60 multiplied by 1000 divided by 3600, right? So that must be the answer, right? So let's carefully apply the values, right? So P times, first apply T as 10, right? 10 minus, then apply 0. So P times 10 minus 0, you know the answer, that is P times 10, right? Okay. So then here also you know 7188 V times, first apply T as 10, right? Or T equals 10. 10 minus, substitute the lower limit, minus 0, right? That means 7188 V times 10, right? Okay. Plus M times V squared divided by 2. So now here what is V? V is, be very careful, 60 multiplied by 1000 divided by 3600 whole thing squared divided by 2 minus 0, right? So now in this part, if you carefully do the simplifications, right, you will obtain the value of P. Actually now what is P here? This is the minimum power required by the V's, right? So here we can substitute value for the mass, right, and also for the velocity over here. So P times 10 equals 7188 times V. Be careful to apply in standard units. 60 multiplied by 1000 divided by 3600 times 10, right? So one segment is here, right? Plus M times, what is M? 1700. Okay. Then V squared, 60 into 1000 divided by 3600 whole thing squared divided by 2 minus 0, you don't have to worry. So keep it like that. So carefully if you do the simplifications, right, so you will get the final answer in watts, right? Because what is the standard unit? 136,764.16, right? So you will get the standard answer in watts, 136,764.16, right? So doesn't matter, you can convert this into kilowatts, right? Just divide this by 1000, 136.7 kilowatts, right? So 136.7 kilowatts, so that means it would be much better if you can keep this up. So it would be much better if you can round this up to 137 kilowatts, right? So let's keep the final answer as 137 kilowatts, right? So now what is the required power at the wheels under these resistive forces? 137 kilowatts, right? So that is